Hello? All right, so I got 4 o'clock now my time, so I'm gonna go ahead and kick it off. Let's see. Thank you for hosting the webinar. Of course, you are welcome. My pleasure. Like this little note says here, we got a little bit of a delay, so I'm gonna be a little bit ahead of you guys. So when you post a question, I'm gonna have to think back 30 seconds ago of what I was just teaching at the point, but that'll be fine. So welcome back, everyone. Welcome to week 2. I know we had a little bit of technical difficulties with a few things last week, but things should be going a lot more smooth here. We're gonna completely forget Git and all that. We're just gonna be learning only programming and Python. So let's go ahead and do a little bit of a review of what we did go over last week. So I'm going to open up the Learn Python folder that we created. All right, I'm going to open up my command prompt in a different window. And put them side by side. And actually, I'm even going to put one up in the corner like that and one down like that. And I'm going to right click inside the folder. I'm going to click new text document. And I'm just going to type review.py, click enter. I get this little notification making sure I want to change the file extension name, and I'll just click yes. And then remember how we open Python files, we're going to edit it with idle. So I'll right click, go up to edit with idle, and then select edit with idle. And then I'm going to drag that all the way over to the side there. So a little review from what we covered first week. All right, week 1 review. First up, we learned what comments were. All right, so this is a single line comment versus this is a multi-line comment. And then, so yeah, comments are pretty easy. On top of that, we also learned what strings were, right? So I can make a string called my name, a variable called my name, and it's going to hold a string data type. I'm going to assign the string data type. I'm going to assign the variable with my actual name, the value of my name. I'm going to assign that Adam. And then remember, we can print out strings that are variables. Pretty easy. I'm going to control save that. We're in the command prompt. Remember, we got to navigate. I want to run this program here now to make sure that this actually works. So inside the command prompt, in order to run a Python program, remember, we got to first navigate to our folder. So right now, I'm in this folder, this directory. So figure out all the files in the directory. I'm going to type in dir, or if you're on Mac, you will type in the command ls for list. And I'm just going to go navigate to my desktop. So remember, to change a directory or change folder, you're going to type cd and then desktop, because that's where my that's where this folder is here, the Learn Python folder. So then again, see all the files in here, and I'm just going to cd learn-python or whatever. Oh, type that wrong. cd learn python or whatever you happen to name your folder. So now we're in here, and again, one more time, if you want, we can check all the contents in here. We have 3 programs, hello world.py, myname.py, and review.py, which obviously shows perfect right there. So in order to run this program, I'm just going to type in review.py, and it prints out my name just like we expected it to. Again, for a Mac, I think we troubleshot this last time. You have to type in Python and then the file name .py. I believe that's what it was. But continuing on, so yeah, we can print strings pretty easy. We can also, let's say we change. Let me just comment this out quick. All right, we can have another string first equals Adam, and then last equals Allard. And then I can create a new string off of these 2 strings. I can say, I can create a variable named full name and set that to first plus last. And then if I print that, notice how, though, there's not going to be a space in between there. So if we go and run this over here, this can join like that. If I want to actually do the space, I need to go back inside this variable, and I need to manually add that space. So plus quotation mark, and then add a space in there, and a quotation mark, and another plus and last. And then if I save that again, and go back over in the command prompt, press the up arrow key to get the last command that I ran, which is just the program that I wanted to run, and press enter again to execute the program, then you can see that it added the space in there. Another way of doing that as well. Yeah, another way of doing that, I could type in print first comma last, and then that way it'll automatically add in a space for you. As we can see, there's the first one coming from that one, and then there's the second one, which comes from this line here. I don't think I got into this last time, but a few other things you can do with that. The reason you'd want to put in a comma here instead of doing it this way, because like I could also type in first plus space plus last, just like the full name. Instead of making a variable with that, I can just put this directly into a print function. And of course, as you would imagine, it executes just the same. But the reason, a more common reason why you want to go to this line here, where you have a comma in between two strings, is when you're trying to insert a variable that's an integer. Remember, we talked about integers last time. So like if I try and print first plus the number 5, like maybe I wanted to print out this here. Atom 5 for some reason. So I type in first plus 5. That's not going to work. You get an error here because it's basically telling us that we're trying to add a string and an integer, and that doesn't make any sense logically. So let me comment here. This doesn't work. Use the comma method for print. So instead, we could do print first comma 5, and then we can see what that does. And of course, oh, I need to comment this one out. That's why. So then save that again, and then run it, and you'll see atom 5 there. Or another thing we could also do, print first times 5. This one, on the other hand, will work, because now this is saying I want you to print this variable 5 times. So let's see what that does. And that will work. 1, 2, 3, 4, 5. Like I said, if I'm going too fast or losing anyone, I'm periodically checking the comment section of the live chat section. So go ahead and post something on the post your question there or whatever. I'll get back to it eventually, hopefully sooner than later. But all right, then continuing on. Let me go ahead and just comment all of this out now so we get a clean working copy here. And let's go back on to numbers and math, and we'll learn a little bit or review a little bit about that again. So remember, we can print out 5 plus 2. I'm just gonna copy that, Control C, Control V, Control V, Control V. All right, so we can do addition, we can do subtraction, we can do multiplication, we can do division, we can do the modulus character, we can do exponents, and then here's something I want to get to. We can also do floor division. I called this the square root function before. I apologize, I was actually wrong on that. This is this double division sign here. That's actually called floor division, and I'll get to that in a moment here. So addition, subtract, multiply, division, modulus, I think that's how you spell it, exponent, and then floor division. All right, so first, let's just print all these, and let's just see what these do right off the bat. All right, so we got 5 plus 2 gives us 7, 5 minus 2 gives us 3, 5 times 2 for 10, 5 divided by 2 gives us 2.5. All that should be self-explanatory. 5 mod 2, remember that gives us the remainder. So 2 goes into 5 2 times evenly with the remainder of 1, because 2 times 2 is 4, 4 minus 5 is 1. So that's why we get a 1 for the remainder. That's what the modulus does. Remember, gives remainder after division. All right, the exponents, pretty self-explanatory. 2 or 5 raised to the second power if I put in 3 there instead, see 125, because 5 to the third power is 125. And then this one, floor division. Like I said, I apologize for getting that wrong last time, but floor division, it's kind of like the opposite of the modulus. So, you know, we're taking the mod here, we're taking the remainder. But for this one, we're taking the actual integer. So 2 goes into 5 2 times evenly. So that's why we get a 2 there. Versus if I would do 5 floor division for 3, our answer should be 1, because 3 can only go into 5 1 time evenly. So if I run that program again, and we'll see now it equals 1. So that's what floor division is. Like I said, sorry I got that wrong last time. Hope it's a little bit more clear up now. There is a function in Python for a square root. By all means, go research that on your own. This is just a little bit of review of what we were covering last time. And I think that's about it so far. Oh, and then we also did the all right, so now let me comment this. So we also got input from a user as well, right? So if I want name equals input, what is your name? And then I can print that variable that the user inputs. So if I save that, go back into the command prompt, press the up arrow key, press enter, run the program. What is their name? I'll type in Adam, and then it just prints out what I typed in. And run it again, and maybe Jimmy Bob, and then it's going to print out Jimmy Bob. So that's a little bit of review of what we covered last time. Nothing too technical. I'm hoping we can get through a little bit more basics today, and then we have some pretty cool programs that we're going to be building towards the second half of this webinar here. And then of which the last one that we will build, I'm actually going to help you guys create the template for it, and I'm going to have maybe like a little bit of a homework session for you guys to try and figure out all the rest of it. It's actually going to be pretty fun. It's one of the first programs that I built, and I definitely had a lot of fun with it. So it'll give you guys some really, really good practice later on. But anyways, let's kick it off here and let's keep going. I'm going to right-click, new text document, delete all that. I'm going to type in week2.py, press enter. Yes, I want to change the file name. And then right-click on week 2, edit with idle, and edit. All right, so what we're going to be learning now, we're going to learn a couple more things. All right, we're going to learn Booleans, or bool. Some people call it Boolean, some people call it Booleans, or other people just call it bool. But all this is really simple. A variable that is either true or false. That's it. Another way of thinking about this is on or off, or 1 or 0. Same exact thing. So what am I meaning by this, right? Like, let's say I have a program to turn off my light switch, right? I have my home automation system, and I want to figure out if my light switch is on or off. Well, I'll create a variable called light on, and I'll set that equal to false. So if I want to see, this is getting a little ahead of ourselves. Because I'm gonna be touching a little bit on conditionals right now also, which I'll explain that in a moment. But so this works great if we want to do if light on, and we'll print your lights are on. Now if I control save this, and then I go back over to the command prompt, and then I'll run the program by typing in week2.py and press enter. Notice how nothing happens, because, and like I said, this is getting a little bit more into conditionals, but I made a variable, and it doesn't matter what the variable name is, I just made a variable and I set the value to false. So this conditional is saying if this value is true, then execute this line. But as we see right here, this value is set to false, which means that this line won't get executed. Without getting into conditionals, I can just print light on, and type. Print light on. Let me comment this out for now, just so we don't get confused by if-else statements. And then go back over into the command prompt, run the program, and you can see it's going to print out false. If I change this to true, press Control S for save, go back over to the command prompt, run it again, and now it's going to print out true. Now, let me uncomment this conditional, and we'll jump right on it. And then that's pretty much it for booleans, however you want to call it. That is very simple. It's a variable, just like a string or any of the numbers, like a double or an integer. It's just a variable that is set to either true or false. That's it. So very simple. Now let's get on to conditionals, which works very well with booleans or bools. So conditional. If, elif, and else. Test for a condition. If true, do code inside of the conditional. Hence the name conditional and condition. Conditional, condition. So right here, so I'm saying if, then condition. I'm testing this variable. I'm testing if it's true or if it's false. If it's true, I'm going to execute the code that's inside of this conditional. And I say inside because Python's very picky with this, all right? So when we have a conditional, we're going to put a colon right here. And then idle automatically indents for you. But whenever you have code, what we call nested or inside of other code, like this code is inside of this if statement here, we need to have exactly 4 spaces, 1, 2, 3, 4, which is just a tab inside most Python-oriented text editors like idle, like what we're using here. So like if I have 3 spaces, 1, 2, 3, and I want to say print, I don't know, print this line here, just for a test line, you know. I'm going to Control Save. Notice this one has 4 spaces here. This one only has 3. I'm going to run this code. Let's see what happens. Get an error. Undent does not match outer indentation level. And like I said, Python is very, very picky about how you indent. You talk to any experienced Python programmer, they're going to tell you straight up, you need 4 spaces for indenting. So, yeah, that's what that is. And then if we want to do code outside of the conditional, we just go back outside of the indentation, so no spaces now. So now I can say print outside of the if statement. All right, so if I Control Save that, go back into the command prompt, run the program, you see it prints out true because of this one. I'm going to comment that out now so we don't see that ever again. And then, so we're testing this condition. If light is on, well, let's check up here. Is light on? We set it to true. So yes, light is on. So we're going to execute this code. And then it's saying your lights are on. That's why we get this here. And then outside of the if statement, we print this line. So if I go up here and I change this variable, this light on variable, to false, and then I save that, first off, what do you think is going to happen? Give you a moment to ponder that on your own. All right, hopefully you got the right answer or figured it out before executing the program. But if I type the program now we just see outside of the if statement. So all this code, and we can have multiple lines of code in here. Anything that is indented to 4 spaces directly after this colon here, directly after this if statement, is inside of the if statement. If the if statement condition is false, any of this code will not get executed. So this won't get executed. Or this either, you know, so on and so forth. Unless we change this back to true, and then all of this would get executed. So hopefully you understand that a little bit better. Let's try. Let me comment all this out. So that's strictly just for if. I put up here if, elif, or else, which this one stands for else if. because we can do this multiple times essentially. So let's make another variable called age. I'm gonna set that to 0. All right, new baby boy born, his age is 0. So now I'm gonna say if age is greater than or equal to 16, print you are old enough to drive. Right, because when you're 16, you're able to drive. So control save that, come over here, run the program, and of course nothing happens because our age is only 0, it's not 16 yet. If I change my age to 15 and I press save, control S for control save, go back over here, run the program, still nothing happens. But then if I change it to 16, save it, come back over to command prompt, run it, and now you can see you are old enough to drive. All right, so let's change it up a little bit now. Let's say right above this first if statement, I'm going to type in if age is greater than or equal to 18, print you are old enough to drive. You are old enough to vote. And then down here, instead of if, I'm going to say elif. And instead of greater than 16, I'm going to say if age is greater than or equal to 16 and age is less than 18, then I'm going to say you are old enough to drive but too young to vote. And then else, you are too young to drive and to vote. So hopefully you're understanding what's going on here. So if you're if your age is equal to or greater than 18, I know it's greater than or equal to, but either way, if it's greater than or equal to 18, we're gonna execute this line. Otherwise, if it's not, that means it must be less than 18. So then we don't execute this line here. We're gonna jump to this line. We're gonna test this line now. Else, if age is greater than or equal to 16 and it's also less than 18, then we're gonna execute this line. Otherwise, and the only way that can't be true and that can't be true is if it's less than 16 then. So that's else, you are too young to drive and too young to vote. So with our age set as 16 here, I'm going to control save that and run the program over the command prompt, see what that does. And then 16, you're old enough to drive but too young to vote, which makes sense. If I change that to 15 over here, and then go back over here and run the command or run the program, it says you are too young to drive and to vote. And then if I were to change that to 18 and go back over here, run the program, you're old enough to drive and old enough to vote. If I'm really old and I'm 999 whatever thousand, control save that, run the program again, and same exact thing. No questions so far, so hopefully everyone's following along. Awesome. All right, so that's those are conditionals. So if, else, else. The program that we'll be building later is going to utilize this a little bit more. So we'll understand that a little bit more as we go on. Hopefully that should be enough for you guys to fully comprehend. I'm going to comment all that out, and we're going to continue on here. What else we're going to do? Oh yeah, lists and loops. We're going to be the last things we do here. So what do we start off with? Let's start off with lists. All right, list, or more commonly known as arrays in other languages. And as you can imagine, a list is just a list of items. All right. So every item in a list or array, same thing, is called an element. Okay, just a little bit of terminology there. And now this is a big thing. Elements in arrays or lists are 0 indexed. No, stop. Hold up. First, a little bit more terminology, sorry. Before that, an element's position is called its index. And then elements and arrays are 0 indexed. Just remember that, and I'll show you what that means in a little bit. All right. First, let's create a list. I'm just going to call it my list to make it easy. I know let's make it something a little bit more defined. So I'll name it animals. Animals equals. Now to make a list, we're going to make a list of strings here first off to start. So a list is going to be contained inside brackets. So we have an opening bracket, a square bracket, and then a closing square bracket. And then everything inside of that will be our list. And it's all going to be separated by commas. So like I said, like as you know, strings are contained inside either double or single quotation marks. So for animals, there's going to be a list of my favorite animals. All right, so it's going to be dogs, comma, another quotation mark, and then cats, comma, another string. Monkeys are pretty cool, I guess. Comma. Let's get some elephants in there. Comma, and then what about a kangaroo? They're pretty cool animals, right? All right, so there's my list of favorite animals there. So pretty standard. We can print the list. All right, print animals. I'm gonna control save that. Go see what that does over here, and then it just prints out the exact same thing that we typed, except it has single quotation marks. Because like I said, strings can be either double or single quotation marks. Doesn't really matter. So that doesn't really look too pretty though, right? Because that's just exactly what we wrote there. I'm going to show you guys, once we learn loops, I'm going to show you how to make that a little bit, print out a little bit prettier. All right, so what can we do with lists though? Let's say I want to get the first item from my list. I want to print out dogs. All right, how am I going to do that? I'm going to print animals bracket at dogs. All right, and I want to get the first element in my list, so I'm going to put a 1 there inside brackets. I'm going to save that. Let's go over here and run it and see what that prints out. And then, hold on, let me comment out this one. Like I said, I'll show you how to make it prettier next time. And then save that, run it, and then cats. We get cats for some reason. That's in the second position when I wanted the first. This is where this statement here comes very, 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 very important. Elements in arrays or lists are 0 indexed, meaning that this position is the 0th position. This position is the 1st position or the 1st position, 2nd position, so on and so forth. So this is index 0. This is index 1. This is index 2, index 3, index 4. So if I want to get the first item in my list, I need to access the index position 0. So save that, run it, and then I get dogs. All right, let's make a comment to remember that. To get the first element, access index position 0. So then as you'd imagine, to get the second element, access index position 1. So if we want to get cats, we're going to do animals at position 1. Control save, and then run the program over here. Oh, I spelled it wrong. And then we get dogs coming from right here, and then cats coming from right here. Another cool thing we can do with lists is we can get the length of them, or the size, or how many elements are in the list. So find out how many items are in your list. Actually, I'm going to say find out how many elements with parentheses or items are in your list. And to do that is going to be the command len then my list name. All right, that's the function of how to do it. So I will print that function then. So I'm going to print, open parentheses, len, another open parentheses, my list name, which is animals, and then close parentheses for the len function, close parentheses for the print function. And then press Control Save, come over here, run it, and it shows me 5. So yeah, that kind of seems silly. Like I can easily just count how many items are in here, and I can count that I have 5 animals in my favorite animal list. But once you start making some really complex programs, you're gonna have, oh, let's see here. I've got a question. It says list index out of range when I try 1. Okay. Do you have more than 1 item in your list? Because I can make a new list here. I'm going to call it fake list equals, I'm just going to give it the number of 55. And if I want to access print fake list at 1, I'm going to get that same error. 1 list is out of range. You have 5 items. Okay, print. Type in the live chat what your command. Type in the live chat the actual list you have here, and then your actual command to print it out. Do you have it exactly as I have it there? Oh yeah, it's really delayed. Index out of range. All right. Well, what you're working on, like I said, type in the live chat just like you were doing the exact code that you were typing in, and while you're working on that, I'll continue. Oh no, here we go. All right. Animals equal. Oh, okay. So what you're doing there, let me type in, hopefully you all can see what I can see. I think you can, but just in case you can't, what's going on is we're doing something like this here. All right, so we're saying, let's say I have a list of names, and then I'm going to give it name Adam, comma, Bob, and comma, Fred. All right, I'm going to close that out. Oh, did that wrong there. You can see here, though, remember a string? My string equals Adam. I need to enclose every separate string inside every one of their own quotation marks. Okay? So if I want another string, it needs its own set of quotation marks. That's what's going on in here. What you want is 3 separate strings, but what you are showing is just 1 string. So your list is only showing 1 string. So what you need to do in order to fix that is do string enclose inside its own quotation marks, comma, and then create another string inside its own quotation marks and another comma, and then again its own string again inside its own quotation marks. And then that should fix your problem there. All right, so actually I probably should have kept that on there. Let me comment that. Strings inside lists need their own quote marks, short for quotation marks. Cool. All right, we're on the same page now. So where was I here? Let me delete all that. Okay, yep. All right. So like I said, we can get the list here. I'm gonna comment all these out here just to make everything a little bit more clean to figure out what I'm doing here. And I'm gonna comment that out too. All right, so now we're working here. So like I said, I want to get the length of this list. So I'll go back in here and we see 5. Oh yeah, like I was saying. Yeah, we can easily just count how many elements are in this list. But later on, when you get more complex programs, there's going to be like hundreds and thousands of elements inside one list, and you're not going to sit there and count every one of them. So that's why this command is so great. And another reason it's so great, because let's say I wanted to access the last element in the list, and I think Python might have a shortcut for this, a function for this, but other languages don't, so it's good to have it to try and learn this form of this method or this implementation of doing it this way. So let's say we wanted to access the last element in the list. Well, remember, if there's 5 elements in this list, I'm not going to access position 5 because that would be out of index, because our index is 0, 1, 2, 3, 4. So to get the last element, I need to access position 4. Or what I could do is use this function to get the list and then -1. So I'll say print, all right, animals at position. All right, remember to get the position, you need that inside square brackets. So I want the position of len, open parentheses, animals, end parentheses, because this part right here, what I have highlighted, that's equivalent to saying 5 right now. So then I'll say that -1. So now inside of here is saying 5 -1 or 4. So now all we're saying is access animals at position 4, or in other words, the last element in our array. So I'll save that, go run that, and it should say kangaroo. There we go. And then one more thing with there's so much you can do with lists. I'm sure one thing you're thinking is, can I add a list? Can I add something to a list? Python's very, very easy for that. Like we said, we know we can do print 5 items. So now if I want to add an item to my list, add an element, I'm going to use the index position 5. I'm just going to say, oh, what was another lion, Simba. Here we go. All right, and then now print animals again. Control save, come over here and run it. Ooh, no, Python doesn't do that. Okay, so you cannot do that. This does not work in Python. I think JavaScript allows you to do that. Let me comment this out. This doesn't work, but what will work, okay. So let's print, let me comment these out. All right, so this won't work. In other languages, it will work. But let's see what will work. So if I print out the array right now, it's going to print out the array as is. And then if I want to add an element, I'm going to use the append function. So I'm going to say animals.append, and then put a pair of parentheses. Inside the parentheses, I'm going to put what I want to add to it, what I want to append to the end of the list. So now I'll say lion. Now if I print the list again, let's see what happens. I print the list as I coded it in here, and then I add an element, lion, and I print it again, and now we have lion. Like I said, there's plenty of functions that you can do with lists. I'm not going to get too much into them right now, especially since we only have 20 minutes left. But go ahead and search them up. There's so much stuff you can do with lists. It's insane. Anyways, continuing on. Speaking of lists, let's see what else we can do with them, as well as learning a new concept, which kind of fits more along the lines of the if-else statements or conditionals, and that's going to be loops. All right, loops are very, very helpful. 2 types of main loops we're going to be doing, while loops and for loops. They're kind of similar, especially in Python. I mean, they're similar across all languages, but Python's a tiny bit different with them. But what a loop is it's essentially continuously running an if condition until until the condition no longer meets, essentially, until the condition is no longer true, okay? What do I mean by that? Well, let's do age. Let's go back to our age example. I'm going to say age equals 0. So now while age is, less than 16, okay? And then same thing, if the loop, just like the if statement, so to have code inside of this if statement, we need the indentation, we need 4 spaces, okay? So that's why it puts an automatic indentation there for us. Age is less than 16, print, you are too young to drive. All right, same thing. Now let's pause and think, what do you think is gonna happen right now? All right, is it gonna print it 1 time? Is it gonna print it 16 times? Is it gonna print it 100 times, 1,000,000 times? I don't know, let's find out. Go ahead and run the program. And we can see it looks like it's printing this amount of times, right? But if we look over here and it's continuously going down, and that's because it is continuously and continuously and continuously keeps on executing this line of code here. So to exit that, you're going to press the Control C, and that's going to be a keyboard interrupt. I really should have looked on it on Mac. I think Mac's the same. Yeah, because it uses Bash. It's got to be the same. Please do a quick comment if it's different on Mac, but it should be the same. Anyways, so what's happening here? A while loop. This is what's called the infinite loop, first off, right? Infinite loop, all right. User beware, right? Because this can get you in a lot of trouble. If you're not careful and your program starts acting really weird, you know what's going on. You have to start tracing code. Eventually, you find an infinite loop just like this, because they're not going to be as clear cut as this one is, right? It's not going to be as easy to tell or understand, easy to find, easy to catch as this one is. That's what I'm trying to say. So how do we not do an infinite loop? Well, we need to make it so the condition finds a point or comes to a point where it is no longer true. So while age is less than 16, print, you are too young, can't type today, to drive. And then first off, going back to this infinite loop, all right, to make this comment a little bit easier to see. And remember, if you want to break out of a comment, you just don't indent anymore. And then if I type in, you are now old enough to drive, because the loop is, because at this point, you're no longer in the loop. However, this line of code will never get executed. This will never get executed in this implementation, because there's no, inside this while loop, there is no way for age to ever become greater or equal to 16. So it's going to run this line of code. I didn't explain that part either. I'm sorry. So a while loop, you're going to run. So if the condition meets true, you're going to run all the code inside the while loop. Once you're done running it, then you go back up to the top and you test this condition again. If it is still true, then you continue to execute every single line of code inside the while loop. In this instance, we only have 1 line of code, but no, imagine if we have a bunch of different print statements, you know, print this line too, or so on and so forth. So it's going to keep on, it's going to run it once, check it again, still true, all right, keep on running it, check it again, still true, all right, keep on running it, so on and so forth. So we need to figure out a way to, at some point, to allow age to break out of this loop, you know, to be greater than or equal to 16. So that's why we need at the bottom. So now back down here, what we're going to do is we're going to say age now equals age plus 1. You know, it's your birthday, you gain a year. So let's say this line of code identifies your birthday, right? It means your birthday's here. So now if we run this code, now what do you think is going to happen? Right? We're going to test age, which we defined up here. And then is age less than 16? Yes, it is. So execute this code. All right. And then once you get to this line, now age equals 1, so on and so forth. So we can imagine it's probably going to run 16 times. And sure enough, if you count all those, it's 16 times, and then break out of the loop. Print You are now 16. You can now drive. And then just to verify that, we will even print out age. All right, control save, go back over here and run. And now it does the same thing. It executes this line of code, well, these lines of code 16 times. And then once it is 16, it breaks out of the loop and then finally executes this line. You are now 16, which you see here. And then it prints out your age to verify, yes, you are actually 16. All right, so that's the while loop. All right, definitely run out of time here, trying to speed up a little bit. Now let's go to a for loop. For loop, very similar, except you're giving it a predetermined amount of times to execute, right? So now I'm going to say for number in range of 0 to 16, print number. All right, control save and then run it. And then, all right, I'm sure you're probably thinking, what in the world just happened there? So I'm defining a temporary variable essentially, and I'm just going to give it some arbitrary name like number because I'm dealing with numbers here. So I'm saying for number inside this list. I made a list on the fly using range, and this list is going to start at 0 and it's going to go up until 16, but not including 16. And then it's going to run this list, or it's going to run the commands inside the for loop, just like the while loop, as long as it's still true. And we're testing if it's still true, if this part, if it's still, in this case, still within this list. So if the number is still within this list, then it's going to run this code. And our number, again, is from 0 up until, but not including 16. That's why we run the list, run the code, and we see 0 all the way up until 15. If I wanted to include, let's say I wanted the actual numbers of 1 to 16, well, then I would just start at 1 and go up until 17, because that would be 1 up and 2, but not including 17, so that'd be 1 to 16. So control save that, run it again, and we print out the numbers 1 to 16. That's not very useful though. You know, that's just kind of showing you what the for loop does. Where it comes in handy is, let's go back to this over here. I'm going to scroll up and I'm going to print out, I'm going to do this. I'm going to copy this code here, where we created the list and then we printed it out just as the actual list form as we wrote it. I'm going to uncomment that, okay? And control save and run the program. See what that does. We already know what that does because we've already done it. So now our for loop, okay? So I'm going to say for animal in animals, print animal. I'm going to go back over here and run it, and we can see it still prints out. Control save. Now we can see, now it prints out nicely. It prints everything on its own line, right? So hopefully you can understand that. If you could understand this, you should be able to understand that. They're the exact same. I know it looks a little bit weird, but I'm making a variable, and I can name this anything. You know, I can name this test, and then print out the variable test. It's going to run the exact same. I just like, which is common convention, to make it something more detailed, right? So for every animal inside the animals list, I'm going to name it animal for every instance. So I'm going to run this code, and it's going to go to the first animal, which is dog. And then as long as there's still elements in the list, this for loop is going to keep on running. So that's essentially what for loops are doing. All right. I'm definitely going to be going over the time limit. Full disclosure here. If you want to kick out at 5, by all means, go ahead. I won't be offended by any means. I'm just letting you guys know I'm definitely going to be going a little bit over to get through everything I want to get through. But I'm pretty much done now with all the definitions, and we're going to do 2 short little programs which are going to help instill all this new information, kind of bring it all together. So I'm going to close that out now. I'm going to make a new program, a new text document, and I'm going to name it foobar.py. press enter. Yes, I want to change this file extension. Right click, edit with idle. All right. So now, this foobar is going to help us understand a little bit more about if and elif and else statements. All right. I'm gonna do this one kind of quick because I'm not even gonna get. I'm not even gonna get in this one right now. If you want, email me after this, and I'll send you the source code for what I was going to have us do, and then you can try and figure it out from there. But we're gonna do this other one because it's a lot more fun. Definitely, it's gonna give you guys some homework, and it's gonna be a fun program. I'm excited for it. So let's get on to it. I'm gonna call it converter. All right, converter.py. All right, so again, right click, edit with idle. Okay. Converter program. All right. Convert between different units of measurement. All right, so in the first example, we're gonna create a program that allows us to convert between Fahrenheit and Celsius. Okay. So in case you don't know the conversion factors already, if you have Fahrenheit and you want to get to Celsius, well, that's going to be, what is it? Yeah, 5/9 times the Fahrenheit, I think minus 32. Yeah, minus 32. So if you have Fahrenheit, you take that amount of degrees, subtract 32 from it, and then multiply that by 5/9. And then on the other side, if you have Celsius, and then you want to get to Fahrenheit, that'll be 9/5 Celsius plus 32. Okay, just a little background info in case you didn't pay too much attention in science class. So how do we do this now? First up, we're going to need some input from the user. All right, so we're going to type in something like a print. What unit are you starting out with? And we're going to have them give that, and I'm just going to do that, yeah. And then I'm going to say unit equals input. We've done this one before. And I'm going to give him sort of like an option. He's going to type in F or C for either Fahrenheit or Celsius, or her. Don't want to be only males. Here we go. So then the user will type in Fahrenheit or Celsius. All right. And then we need another thing. We need another. So now we know if he's starting out with Fahrenheit. Now we know if he or she is starting out with Fahrenheit or Celsius. So now we need to print how many degrees of unit, whatever unit the user is using, do you have? And then type in degrees equals input, and we'll get the input from the user again. And now let's just print out a little test, okay? And I'm just going to print out unit and degrees, okay? Let's make sure we have this good to go so far. This is very good practice to do. Write a little bit of code and then test it out. Make sure everything's on track, okay? So I'm going to control save that, and then I'm going to run the new program, converter.py. What units are you starting out with? I'm going to say, I'm going to change it up. Fahrenheit, how many degrees Fahrenheit do you have? I'm going to say 212. And then it's going to show me you're using Fahrenheit for 212. Okay. That looks a little ugly though. I'm going to delete those parentheses there. I don't know why I put those in there. All right. All right. So now a little bit of a logic we need to do. All right. We need to set up new variables to convert to. And then we're also going to fix user input. All right. So let me actually first fix user input. So I'm actually gonna, sorry, I'm just gonna do that. Let's first fix user input. All right. So let's go back here. Let's look, and what if I would have typed in lowercase f? We want it to be able to, we want the program to be a little bit smarter than to just only accept capital Fs, right? So I'm gonna say unit now equals unit dot upper, which is a Python. It's just a Python function, which is going to automatically convert this variable to all uppercase. So in our case, if we typed in lower f, it's going to automatically convert to capital F. And then also to fix the user input, we also need to cast this to an integer because we want the amount of degrees to be an integer. Remember how I said last week how there's different data types? You know, we have strings and there's integers, which are whole numbers, and then there's double or floats, which are just decimal numbers. You know, like 3.14 is a float or a double, so on and so forth. Well, we need this to be a number, and actually we can actually cast that to a double even, or a float. So I'm going to type in, this is how you cast a string to a float. Because when this command here, this is inputting a string, but we want it to input a decimal number. So I'm going to say float, and then enclose all that in parentheses. And then if I save that now, I run the program again, it should work the exact same. But if I type in lowercase f and then 212, oh, I didn't print out the thing earlier. So if I print out my test again, unit, and then degrees, control save, come back over here, run the program, lowercase f, and then 212, see that it automatically converts it to an uppercase f, and that automatically converts it to a number, a floating point number as well, which is what we want. All right, so that's fixing user input. And now we need to create new bars or variables to assign or to convert to. Because I'll show you at the end why I'm doing this, because essentially we want to still keep the old data for printing out. And I'll show you what that means at the end. But so we're creating new variables now. So we need a new unit, which is just going to be the opposite of whatever one we're doing. So new unit, and I'm just going to set it to Fahrenheit just for default. We will change this later. All right. Might not stay Fahrenheit. And I'll say new degrees equals -999, just for dummy data. Again, might not stay -999. I'm actually going to put you as a 0.0 there. All right. So now what do we do? So now we need to be able to figure out if the user is starting with Fahrenheit or Celsius. How can we do this? With our handy dandy new if-else statements. So if unit is equal to, I didn't get over that. All right. Two equal signs. If unit is equal to Fahrenheit, okay, and let me stop here. Well, true equal to, what's going on here, right? Right here, we are assigning a variable. Right here, we are assigning a variable. All these, we are assigning a variable. All right, little side note. 1 or equals does not equal 2 equals. Equal is for assignments. Equal is for testing conditions. All right, otherwise known as is equal to question mark. So if unit is equal to Fahrenheit, all right, continuing on, then we're going to, again, dummy data, do, let's say, var to cell for Fahrenheit to Celsius, else if unit is equal to Celsius, print cell to var, else, and And if it's not Fahrenheit or it's not Celsius, the user entered in some wrong data. So we're just going to tell the user error, you entered wrong data. Then this would be a point where you have the user re-enter in the data, but that's a little bit more advanced than what we're going to get onto here. Continuing on. All right. So let's just print these, make sure they work. All right. So Fahrenheit 212. All right. So we're going to be doing the far to cell. Good. Let's run the program again. Maybe I start in Celsius this time, and I have 100 degrees. Well, now I'm going to do the cell to far. Awesome. All right. So now, pretty simple from here. Okay. Let's delete this little testing data here. So now I'm going to say, first up, my new unit is going to equal Celsius, because if it was now my new unit needs to equal Celsius, and now my new degrees is just a matter of assigning it the conversion factor. So new degrees, so Celsius essentially equals 5 divided by 9 times parentheses Fahrenheit, or degrees, what the user entered in, degrees plus minus 32. Or on the flip side, if they started out with Celsius, new degrees will equal 9 divided by 5 times degrees plus 32. Okay. And we also need to be consistent. And we also need to assign the new unit equals Fahrenheit. So now let's see why I created these new variables, because I'm going to show you right here. Now, once we're all done with that, that means that we converted the data properly, or it's all done converting the data rather. So now we're going to display the new information to the user. So we're going to print degrees. Am I saying degrees all the time? Yeah, all right, good. So degrees unit is equal to new degrees, new unit. We'll save and let's see if this works. All right. Remember, we're using the for this print function here, we're using the comma way of doing it, which automatically adds in the spaces for us. So really nice, convenient like that. All right, so run the program. What units are you starting out with? Let's say Fahrenheit, and then let's say 212. Now it's going to tell us 212 degrees Fahrenheit is equal to 100 degrees Celsius, which that does work. Awesome. Run the program again. Let's start with Celsius this time. Let's say we have 0 degrees Celsius. 0 degrees Celsius is equal to 32 degrees Fahrenheit. Looking like it's working so far. One more for good luck. Fahrenheit. How many degrees in Fahrenheit do you have? Negative 40. Negative 40 degrees Fahrenheit is equal to negative 40 degrees Celsius. Hopefully you were getting all that so far, and hopefully the program's working. If not, I'm pretty sure this webinar, I don't think it happens right away, but this webinar will be on my YouTube account, and you should just be able to type in the same exact link that you're on now. Within like an hour, I think it's on there, so you can just come back to this spot and verify the code that I have right here is matching with your code, or even email me. I'll explain once I give you this little homework assignment. I'm very open for you guys to email me questions or anything else. So, all right, continuing on, almost done now. All right, so that was that part of it. Now this is the homework part of it. I'm gonna have you guys create this program to make more conversions than just temperature. All right. So this is just the temperature part of it. You guys are gonna create a whole bunch more. We're gonna make it like an actual pretty cool program here. So let's get a nice warm welcome message. Welcome to unit converter, measurements converter. Say that. Measurements converter program. right, and then we'll print. There's nothing amazing. There's nothing important about this part. This is just a little welcome screen essentially. All right. Now we need to give him the first. Now we need to give the user the first menu to go through. So we're gonna say print. What metric are you trying to convert? And then we'll say metric equals input. Oh no, nope, sorry. We need to give them the user a menu now. So let's just make it simple. We'll do one length, two weight, then three temperature, and then metric equals input. So now what this is saying, it's going to print this to the screen, and then we want the user to type in either 1, 2, or 3, and that's going to be the metric that they want to convert to. So now it's going to be a big if statement, if conditionals. So we're going to say if, nope, and then also remember we want to fix the user input. So metric equals metric dot upper. Now, if metric is equal to, let's say the user typed in the number 1, or the user also could have typed in actual length. And I'm putting in all uppercase because I did this here. So maybe like I have it with a capital L, maybe the user didn't type in capital L, maybe they typed in all lowercase, or maybe they typed in all uppercase, or maybe they typed in capital L, lowercase e, capital N, and the rest lowercase for some reason. Well, this is going to change it all to uppercase anyways. That way I can just test it once right here, and I don't have to test for every combination of capitalization and lowercase letters in the word length, you know? So, so if equals that or that, and we're gonna print new length conversion here. And now this is part of your assignment. Okay, man, I can't type. Elif, same thing, metric is equal to 2 or metric is equal to weight. Print to weight converge. Elif metric is equal to 3 or metric is equal to temperature. And then we already did this part, luckily. So remember, everything needs to be indented inside the if statements. So in order to do this nicely without having to go in here and indent and then indent every single time, what you can do is just highlight this entire text and then press tab. And then it should indent it for you automatically like that. Real nice and simple. All right. So, and then what's really cool, I don't know, I didn't go over this either, but we can have, like, this is a nested if statement. So this if statement is inside of this giant if statement, right? So you can put if statements inside if statements, so on and so forth. But yeah, so now we did this. Now let's get a little bit of a Boolean logic in here. And we're going to create a way to continuously run this program upon the user's request. So I'm going to create a bool, and I'm going to name it, oh, this is going to be at the top of the program. I'm going to create a bool, name it play again, and I'm going to first set it equal to true. So now, while, I think I can just, yeah, while play again, and now all of this code needs to stay inside of the while statement. So again, I'm going to highlight it all and press tab. Okay, so while this is true, keep playing again. Once you finish all this code, All right. Break out of that, and then I'm going to say, now we're going to prompt the user to see if they want to play again. So I'm going to print, do you want to make another conversion? And then your answer, let's say answer equals input. Oh, and actually I'll say yes, comma, no. And then we'll go if answer.upper is equal to n for no, then we're going to say play again, the variable play again equals false, because then that's going to be the end of the while loop code. So it's going to go back up here, test the while condition again, which is the play again. If it equals to false, which happens from the user pressing n, then we're not going to execute the code, and the program's going to be done. So we'll break out of that, and then we'll give them a goodbye message. Thank you for using my program. Goodbye. All right, so let's save that, and let's test it. All right. So welcome to Measurements Converter program. What do you want to start with? Let's say 1, and then do length conversion. That's on your part. Do you want to make another conversion? I'll type in Y for yes. Same thing. 2, do weight conversion. Do you want to do it again? Yes. And let's do 3 this time. And then it goes into what we did earlier. What units are we starting out with? We'll do Fahrenheit. How many degrees Fahrenheit do you have? I'll say 46. 46 degrees Fahrenheit is equal to 7.79, or yeah, 78 degrees Celsius. Do you want to make another conversion? And no, I think I'm done now. So I'll type in no. Thank you for using my program. Goodbye. So yeah, a lot of code there. Hopefully it's definitely making you understand how everything all fits together now, though. Like I said, your part of this now is going to be to do this part, figure out, and I mean, to do a length conversion, you can do like miles to meters, figure out the conversion factor there, and then figure out the logic and the math to go in there. Or you could do like feet to, I mean, I guess yards or anything you want, feet to meters, or do weight, you could do pounds to ounces or something like that. And you don't have to stop there. You can keep on extending this. Maybe create another if else for volume and do gallons to cups or something else. So yeah, there's definitely a lot you can do on there, and you're not limited to 2. You can even, maybe if you want to expand temperature, you want to put in the Kelvin temperature scale in there also, or the, what's it called, a Rankine, something like that. The 4th temperature scale. So there's definitely a lot more you could add on to this, and it'll be a very fun program to continue on. If you get stuck at all, by all means, shoot me an email, show me the code that you're working with, show me the error messages, and I'll work the best on trying to help you out. But 15 minutes overboard already. So it looks like one person already kicked it out earlier. So hope you enjoyed this week. We'll continue on next week back at the library. Hope to see you there.